Here are the answers for the day 2 Bell work. Compare the graph of each function below to this function right here, f of x equals the square root of x. Well, if we're going to compare graphs, we need to know what they look like. So in this function right here, when x is 0, the square root of 0 is 0. So the origin is a dot on the graph. When x is 1, the square root of 1 is 1. So 1 comma 1 is on the graph. When x is 4, the square root of 4 is 2. So 4 comma 2 is on the graph. This is called the square root function, and it has this shape to it. When you take a quick look at these functions here, notice they all involve square roots as well. So we're expecting the basic shape to be the same. However, there are all these extra adjustments made in different parts of the formulas. So what happens if you have negative the square root of x? It still starts at the origin, but when x is 1, it ends up making negative 1. When x is 4, it ends up making negative 2. And so the picture looks like this. So if you were going to describe what this looks like compared to this original function, what would you say? It's a reflection over the x-axis. The graph has been flipped upside down. Now what about question B? This still has a square root, but there's a minus 3 in the square root next to x. When x is 3, 3 minus 3 makes 0, and the square root of 0 is 0. So 3 comma 0 is the starting point. When x is 4, you get a dot at the 1, and so on, so you have this shape here. Now, how would you compare this to this original picture up here on the right? They're exactly the same size and shape. It's just that the starting point has been moved 3 units to the right. There's a horizontal shift 3 units to the right. Now, question C. Still got a square root, but this time there's a minus 3. It's not under the square root with the x. What does that cause to happen? Well, when x is 0, the square root of 0 is 0, and then you minus 3, getting negative 3. So 0 comma negative 3 is a dot on the graph. When x is 1, the square root of 1 makes 1, and 1 take away 3 makes negative 2. So there's a dot here. When x is 4, you'd get a dot at negative 1, and it ends up making this shape. Exactly the same curve as the original in the top right. It's just that that starting dot has been adjusted. Now, how would you describe that? We could say that that's a vertical shift down 3. Now, question D, look what we got here. We still have a square root, but there's a coefficient being multiplied in front of the x in the square root. How does that impact the graph? When x is 0, we have the square root of 0 makes 0. So it still begins at the origin. When x is 2, 2 times 2 is 4, and the square root of 4 makes 2. So 2 comma 2 is on the graph. What about when x is 8? 2 times 8 is 16, the square root of 16 is 4. So 8 comma 4 is on the graph, and therefore it has this shape to it. Now, how does this compare to the original that's up there in the top right? We might describe this as being stretched by a factor of 2. Here's an example of what I mean by being stretched. In the top right, there was a dot at 1 comma 1. If we times that by 2, we get 2 comma 2, as shown by this dot. In the picture on the top right, we had a dot at 4 comma 2. If we times that by 2, that becomes 8 comma 4, which is this dot here. I'm using the word stretch to describe that action.